All right, we've covered most of the conversion stuff as far as percents to decimals and fractions to percents and decimals and whatever else I just left out there. The only thing we really haven't talked about yet with the conversion aspect is what does a percent look like when it's 100% or more? And that's what we're going to go through in this section here. A percent that is 100% exactly, and these are just going to be a couple of examples, but we'll go much more in depth with this. A percent that's 100%, the fraction is going to look like the top and the bottom are going to be the same. Okay, so in this example, 5/5, that is one whole, which is 100%. And again, that's signified just by a whole number 1. There's really no decimal after it. So 100% is the same thing as one whole. Another example would be if we had 200%. 200% is the same thing as two wholes. And again, I've got an example of something that would be two wholes over here. If I have 10/5, 10/5 is the same thing as two wholes. It would take 5 to make one whole, and since we have 10, we've got two wholes or twice as much. Another example is if I had 3.6. We're going to talk about these conversions coming up here, but 3.6 is the same thing as 360%. And you'll notice that if we have a decimal in there, that front number is actually the hundreds place, and the next two are just like when we did the percents before, where we took the first two numbers after the decimal point. Same thing here. The whole number is that hundreds place right there, and then I could add that 0 to the back end of it. There's my first two numbers after the decimal point. There's my first two numbers after the decimal point when changing that to a percent. And this could be a fraction, 18/5. That could be a fraction for 360%. These are what they're going to look like, and we'll go over some specific examples. Here are examples of 5 decimals. And these decimals all represent what we're going to turn into percents that would be more than 100%. I can look at all these decimals and I automatically know that they're all going to be over 100% because they all have a whole number in them. Okay? Remember when we just had decimals, like if I had, let's say, 0.67, remember we just took the first two numbers and that was 67%. Remember if I had 0.3, we took the first two numbers, which would be 30, and that would just be 30%. And then remember a situation where maybe we just had 0.06, we took the first two numbers, that was 6%. This kind of works the same way, but now we've got whole numbers in front of these decimals. So for instance, if we have 4.7, that is not, normally if I covered this up, that would be the ones that you would be used to, and 0.7 would be 70%. Now that we have a 4 in front of it, that's going to stand for 470%. Looking at the next one, 2.07. If I covered the 2 up, that would be an easy one. That would just be 7%. But since I've got a whole number out in front of it, and that whole number would represent the hundreds place in a percent, this is going to be 207%. If I come down to this one, if I cover this up and just have the 0.11, that's of course going to be 11%. But since I have the 1 out in front of it, that is going to turn into 111%. On to the next one, if I covered this up, remember with a decimal we only need the first two numbers. So if I covered this up, this would be 62%, or we could say 62.3%. That would be fine. But since I have a 5 in front of it, this is going to have to be 562%. Now, I could always add that 3 on the end of it and do 562.3%. That would be perfectly fine as well. And then my last one. If I covered up this 11, it would just be 0.5. Remember that 0.5 is the same thing as 50%. but it's not 50% because we have 11 in front of it. So our percentage is going to be 1150%, which is just 1150%. I'm hoping that throughout this process right here you can kind of see a pattern for what we just did here. We found the percents like normal, like you normally did. I just covered up the whole number, and then I put it out in front as if it was in the hundreds place here. Here are three fractions that you can clearly tell are improper fractions. Whenever you have an improper fraction, that's automatically going to mean the percentage is more than 100%. And it should make sense to you by now with all our work and everything that we've done. If your bottom number is 8, if your top number would also be 8, that would be exactly 100%. Anything more than that would have to be more than 100%. Same thing for the rest of these. So all I need to do is set up a division problem like we've done before to figure out what this is. Now here's the catch. When we set up this division problem, hopefully you understand that the bottom number goes on the outside and the top number goes on the inside. But if for some reason you mess that up, you should be able to easily tell excuse me, if your answer makes sense. If I divide this out, this answer better be more than one whole. It's got to be, because my fraction itself is more than one whole. So let's put this in the right spot and figure out what we've got here, because we have to go decimal first, then we change it to a percentage. So my 8's going to go on the outside, and I can put my 0.000 out here because we might need that. 8 does not go into 4. 8 goes into 43. I'll put my decimal point here, but 8 goes into 43 4 or 5 times. Okay, 5 times. That would be 40, and we'll subtract, and we'll get 3. Okay, now I still have a 0 to bring down, so let's bring down the 0. 8 goes into 30. That would be 3 times. 3 times 8 is 24. Take away equals 6. Bring down my next 0. Not quite done yet here. Okay, 8 goes into 60 7 times. That's going to be 56. Subtract, and we're going to get 4, and let's bring down another 0. Now if we needed more zeros, we could just keep adding them on, but I don't think we will, because this should terminate right here. 8 goes into 45 times, and that would terminate, because that's 40. Now, here's our decimal. We need to write that as a percentage. And remember what I said, we could cover up the whole number to start with, and write that part as a percentage, which would be 37%. We could say the first two numbers is what we want. We could also say 38% because we could take that 7 because there's a 5 there and round that up to an 8, or we could just use the whole thing and I could make this 37.5%, 37.5%. But with the 5 in front of it, it needs to be 537.5%. So we could write this a couple different ways. I could just simply keep it at 537%. That would be fine. I could do 538% because that 5 would round that 7 up to an 8. Or, technically, this is exactly what it would be, 537.5%. All of those would be acceptable answers. So all we need to do is divide this out, get to a decimal, and then change it to a percentage. Just what we've done before, but this time we've got a whole number in front of it, meaning it's more than 100%. Let's go down to the next one. Let's go down to, and maybe it's easier if I just get rid of this right here. That'd probably be a good idea. Let's just do that. Okay. 15/4. Again, this is going to be more than one whole because the fraction is more than one whole. Okay. 4/4 would be exactly one whole, would be 100%. 8/4 would be 2 wholes, which would be 200%. 12/4 would be 3 wholes, which would be 300%. So I know this has to be more than 300%, but it's going to be less than 400% because if this was a 16, 16/4 is the same thing as 4 wholes, which is 400%. So my answer is going to be between 300 and 400%. But let's check it out. So my 15 goes here, my 4 goes here, 4 goes into 15. I can just bring that right up to start with. 4 goes into 15, what, 3 times? So that would be 12. There's our 300% right there, so my prediction was definitely correct. So we've got that so far. Take away 3, bring down the 0. That's going to be 7. 28, take away equals 2. Okay. Then I got to bring down another 0, and this should come out to be okay. 4 goes into 25 times, which is 20, and there's our answer, 370 or 3.75. Now, if I write this as a percentage, again, if I covered this part of it up, it would just be 75%. But since I have the 3 in front of it, it's going to be 375%. And then our last one is going to be 8/7 that we'll show you here. 8/7. So 8 and 7, and I can do 0.00 if I want to. Okay, and we might need a couple more zeros. I don't know how far this is going to go out here. 7 decimal point goes into 8 once, and you'll notice I put that in front because 7 actually did go into this 8. So I know it's going to be 100 something percent. 7 take away equals 1, bring down your 0. That's going to be a 1. 7 take away equals 3, bring down your 0. That would be a 4. 28. 2, bring down your 0. 7 goes into 21 twice. And I'm just going to stop there because I think we have enough digits for what we need. This could just keep going on forever. So again, I need the percentage here. If I cover this up, that would be 14.2%, or we could say 14%, but with the 1 in front of it, it's going to actually be 114%. Or we could also write 114.2%. Now the last thing I want to show you with this part real quick before we move on, we talked about in one of the other sections that if you can make the bottom number be 100, then the top number is going to be the percentage. Remember, this answer right here was 375%. Just keep that in mind. Now let's say I do this 3/4. 4 goes into 100, I know. So if I do 4 times, that would be times 25 is 100, and I times the top by 25. 15 25s is 15 times 25 is 375. So you'll notice that there's my percentage right there. It's over 100, so 375 is my percentage.